we move on to the most awaited part of the program, our expert session. The first session deals with the topic EV battery life enhancement through cell balancing techniques. It's my privilege to introduce today's distinguished resource person, Dr. Prince A, Principal, Rajiv Gandhi Institute of Technology, Kottayam. Dr. Prince A has graduated BTech from TKM College of Engineering, Kollam, MTech from IIT Delhi, and PhD from IIT Delhi. His duties in the government university levels are Convener, Kerala Technical Education Service Special Rule Modification Committee, Interview Board Member of Polytechnic Colleges, Interview Board Member for Engineering Colleges, Board of Studies Member KTU Kerala, Curriculum Committee Member APJ KTU Kerala, Doctoral Committee Member APJ KTU Kerala at various research centers. He's an IEEE Senior Member, and his areas of research interest are power systems, renewable energy, AI applications in power system. He is a research supervisor of more than 8 research scholars, and he has written more than 8 books. With immense pleasure, we are honored to have you with us, sir, today. Now the virtual stage is yours, sir. Okay, first session is EV battery life enhancement through cell balancing techniques. It's my privilege to introduce today's distinguished resource person, Dr. Prince A, Principal, Rajiv Gandhi Institute of Technology, Kottayam. We are honored to have you here, sir. Sir, can you hear us?
Yes, thank you.
Yes, sir. You can have the session. The virtual stage is yours.
So I was just started with the socio-economic development indicators. I talked something related to human development index, and especially about the per capita electrical energy consumption, which is to be increased or improved to become a developed country. Because the energy consumption determine the development of mainly the development of the country. Um, and as we know, the power sector, especially if you take the entire energy consumption of world, then we can see that around 30%, 31% of the energy is utilized by the transportation sector. So we have to give more importance to the transportation sector. We have to effectively utilize the energy in the transportation sector, and also the energy which is utilized in the any sector. Of course, it is going to contribute to the pollution also. pollution also. We have the industrial pollution and pollution due to vehicles. And since that is a major part, vehicle pollution is a major part, we can we have to give importance to the transportation sector, especially the vehicles that we are using, and that is why we are preferring the electric vehicles or hybrid electric vehicle. That is what we have discussed in the last in a few minutes in the first session, which I was there. And then I introduced, I think, the basic components of an electric vehicle, and where I said that the main component, of course, the traction motor and the power controllers for controlling the traction motor. The power source is basically the energy storage system or the battery. So the battery is, we can say, the heart of any heart of an electric vehicle system, and is very important. We are basically using rechargeable batteries, and when we are considering the cost of an electric vehicle, around 50% of the cost of an electric vehicle is, of course, that of the battery. So we have to give much importance to the battery, and we have to improve the life of the battery system, so that that is going to improve the life of an electric vehicle as well. So that is why we are giving, we have to give much importance to the battery, the research regarding the different type of battery and improving the life of a battery. As we know, as we discuss, the life of a battery pack must be maximum to enhance the life of an electric vehicle. When we are considering about a battery, the storage system in a vehicle, of course, it is having a battery pack, and then battery modules are there in the battery pack, and of course, it is consists of many cells. So we have to understand some basic idea about the battery, the different type of battery, and what are the basic performance parameters of the battery. Battery, we can basically divide it into two type: primary type and secondary type battery. And as we know, the primary type of battery that cannot be charged is the usual battery that we are using regularly, which cannot be charged. But at the same time, we have the secondary batteries which can be charged. There are lithium ion batteries and also the lead acid type of battery, and different type of secondary batteries are available. See, these are the basic rechargeable batteries available nowadays. Lead acid battery, of course, the old one, which we have still, we are using that lead acid battery in many vehicles also. We also have nickel cadmium type, lithium ion battery, lithium polymer type. Different type of batteries are available, and most popular one is now also it is lithium ion battery. In most of the vehicle we are using lithium ion batteries. While considering a battery or a cell, we have to understand, we must have some idea, basic idea about the performance criteria of a cell or of a battery. The specific energy density, these are some basic terms. I think most of you may be familiar to that, but we must understand, or if you want to do research in the field of life enhancement of battery, you must understand the basic these basic terms, especially some terms like specific energy, ampere hour capacity, state of charge, state of discharge, depth of discharge, like that. The designer also needs to understand how energy availabilities varies of a battery with regard to the ambient temperature, the charge and discharge rates, and then size of battery, or many other things you have to understand. Anyway, at least you must know about the temperature withstanding capability of a battery, then about the charging and discharging rate and size of battery. These are some of the important terms. Now, we are familiar with ampere hour capacity of a battery. We know that we all usually express the capacity of a battery in ampere hour, and we usually write that same C. For example, a battery has a capacity of 42 ampere hour. That means we usually write C as equal to 42. Sometimes we will specify the C rating of a battery and how much we can charge or discharge with that particular battery. For example, a 42 ampere hour battery, if it is a 2C type battery, then we can understand from that if 42 ampere is the rated current, then 2C, that is 84 ampere, that in that ampere rating we can discharge that. Similarly, 0.4 means 16.8 ampere discharging current. Many batteries have some specific ampere hour capacity may be there, but it is available only when it is discharged in a specific rate. For example, suppose that this particular one, the ampere hour capacity and discharge time of a particular battery is shown here. This is actually for a 42 ampere hour battery. So if you consider this battery, approximately the 10 hours is required for completely getting that capacity. There is 42 ampere hour capacity. It can be utilized if it is discharged with 10 hours. Okay, then only that fully that can be used. If you are discharging with a short time, then the capacity can also be less. So that means you may not get the full capacity returned in the battery if it is going sudden changes. Um, we usually write if it is 42 ampere hour battery, if it is rated for 10 hours, then we will say that it's a C10 battery. And if you are writing 2C10, that means 2 times, that is 84 ampere hour is amperes is the discharge current with for the C10 battery. C10 battery means it is discharged, the full output you will get only when there is it is discharged with 10 hours. So the discharge, I mean, what we have to understand is the capacity of the battery. Even though we have a return some rating over the battery, it can be charged or discharged with a specific time. Otherwise, some loss of the capacity may happen, which may also affect the range of the battery and also the life of the battery. Another thing is that many battery, the size of the battery, the specific power that can be provided, similar to the specific energy, watt hour per kg. I mean, that is also another important parameter while we are designing a vehicle and the energy storage for the vehicle. Some of this may be familiar to you, so I am skipping some terms. Another important term is state of charge of a battery. State of charge is actually the charge left from the topmost charger position to the time where up to which we have discharged it. It is the amount or the capacity that remains in the battery after discharge from a top of the charge condition. So that is the SOC, state of charge of the battery. And we can calculate the state of charge by many methods. You may be familiar with at least some Coulomb count method and all. So with that, we can measure the amount of charge remains in the cell. That is called the state of charge. These parameters are very important while we are considering a battery. So especially the state of charge, the depth of discharge, the specific energy, all these are very important. If you compare different type of battery. The lead acid battery, nickel cadmium, nickel metal halide battery, lithium ion battery, etc. If you compare all these type of battery, we can see that the energy density uh, and also the energy density is more for lithium ion battery. Similarly, you can see the nominal voltage and also the overcharge tolerance. Overcharge tolerance is very low for lithium ion battery, but at the same time it is very high for lead acid battery. So when that is why we have there is no such it's a specific incidents or the related to lead acid battery. Even when we are overcharging it, it have high overcharge tolerance. So accidents are less with the lead acid battery. But you can see that the energy density is very small, 30 to 40 is the energy density, watt hour per kg is the energy density of lead acid battery. So see, you can see the lead acid batteries self-discharge. For any battery, there will be a self-discharge. So it is low. At the same time, for lithium ion battery, it is very low. So almost all the batteries are working in the range from 20 to 60 degrees Celsius, and the life cycle number of cycles available from the lithium ion batteries much more compared to other type of batteries. So from this comparison, we can understand that um, from the available type of usually popular type of batteries, we can see that of course lead acid battery is still used, but we can see that the lithium ion battery, which is having high specific energy density, that means with a minimum weight we can provide maximum energy. We can take maximum energy from the cell. Similarly, the voltage also is more compared to the other cells. The only problem is found to be in the overcharge tolerance. It is very low for lithium ion battery, but at the same time risk is very less for lead acid battery. So lithium ion battery, that is why people are preferring in the electric vehicle basically. But it is having even we are using that lithium ion battery in the vehicles. We have to observe these criteria to avoid overcharge tolerance, especially to avoid any type of risk involved while we are suddenly discharging it or charging it. While coming to the accidents caused by overcharging, many times we can see that due to overcharging, lithium battery are become damaged, but at the same time it is having very high storage capacity and it is very good for an electric vehicle. So there are many methods. People have done research in battery energy storage system, and many methods are suggested for reducing the risk involved in using lithium-ion battery, because lithium-ion battery is one of the best type of battery which can be used for increasing the range of a electric vehicle. So we have to always monitor and detect the overcharge of lithium-ion cells. So that is why we have a lithium-ion battery management system in an electric vehicle. So battery management system must basically monitor and detect cells overcharge, and also we have to for any battery we cannot bring the charge below a certain level. So we have to always monitor the each cell of the battery pack. We have to monitor and detect cell over discharge and alert the operator. Cutoff system. Cutoff system. We have to also monitor the minimum energy level. Cell balancing we have to do in the system. We will come to this particular point. This is our topic of discussion today. Then also we have to always monitor the temperature. Now, the basic battery management system is will always monitor the discharge control, then charging control, SOC determination, state of charge calculation of the battery cells of the battery pack, and also it always gives some indication about the state of health depending on all these conditions. Similarly, cell balancing, which is another vital function of a battery management system. Thermal control is another important I mean, objective of battery management system. Now, coming to the in the previous slide again, the overcharge tolerance is very low for lithium-ion battery. Otherwise, lithium-ion battery is very good, as I already said, for the storage and increasing the range of an electric vehicle. If you take the electric vehicle, 88, if you take the Mitsubishi's EV 16 kWh battery system, where we have 88 cells, 4 modules, 20 cells in each modules. So if one of the cell become damaged, the entire system become fail. So we have to always check each and every cell, monitor each and every cell, so that we can enhance the life of the battery. The main problem with the cell is shown in this particular figure. You can see the 4 cells are shown here with some energy in that, or the charge, state of charge in that, or the charge stored in the cell. Now, if you charge this particular cell, of course, it is going to, while we are charging, the charge will in each cell will gradually increase. And if you go on charging it, some of the cell become overcharged, because we know uh, every battery, every cell cells will have different capacity. Even if it is a similar type of cell, the cells have different capacities. The non-uniform operating conditions impose different thermal and electrical stress on each cells. Um, the current may be the same. We are giving the same charging current, but the cells may have different SOC, state of charge, and the cells will charge at different rate. And due to that, some of the cells become overcharged. So even though you can see this 4th cell that become overcharged due to a charging process. And similarly, when we are discharging it, some of the cells may over discharge. See this second cell, in some cell number 1, 3, and 4, some charge is left, but second cell become empty. So that means it become below some minimum level of charge. So we have to always monitor it. Otherwise, that particular cell become damaged. So in the charging case, 4th cell become overcharged here. So if you continue in that process, that may break, or that may get damaged. Similarly, when it is discharged, second cell, it is discharged very fast. So there is no minimum charge in that cell, and that cell will show the tendency to get damaged. So we have to monitor this process. So even if you keep that cells without any charging or discharging, there will be a small self discharge. So this process will cumulatively will have an effect, and there will be difference in SOCs, and the difference is due to many reasons. Many reasons that difference may happen. Now, coming to the different methods, cell balancing method, we have to always balance the charge charges in all these cells. Otherwise, this some of the cells become overcharged, or some of the cells become over discharged or become empty, and that may cause difficulties, and that may cause damage to the battery pack. So the cause behind that variation is due to the internal impedance or material aging or many other manufacturing defect or property of that cell. So we have to always monitor such type of cells and make the cell always balanced. Otherwise, that may cause mean damage to the cells. These are the some of the classical methods for cell balancing. There are passive balancing methods and active balancing methods. In passive balancing methods, that removes the excess energy through a passive elements. Every time we will monitor, we can monitor the energy level in the cells, and if one of that is having overcharge, then we can use some external arrangement to remove the excess energy through some passive elements like resistors. The resistor elements will be either in a fixed mode or as a switched mode. Features are simplicity, and the features of this type of balancing method are simplicity and low cost, but it has continuous energy dissipation, and that is actually will affect the efficiency of the system. Similarly, we have active balancing methods that removes charge from higher energy cells and deliver it to the lower energy cell. So every time it monitor and will transfer energy from one cell to the another cell. Here the effectively we can utilize the energy inside the available in the cells, and we can make the cell balance. It has different topologies according to the active elements used for storing the energy, uh, and also for charging and discharging operation. There are many type of active and passive and active balancing methods. In the passive balancing method, basically we are using fixed resistors or switched resistors. And in the active balancing method, there are many methods using inductor or transformers. We can have save energy and then transfer energy to the other cells. Or similarly, we can have power electronic converters, and we can also use that along with the capacitors. Basically, the active balancing method, we are using either capacitor switching method or with power electronic controllers. So these are the representation of cell balancing method with the passive balancing circuitry, and here is another circuitry showing the switched capacitor methods for transferring energy from one cell to the other cell. So here, using the controlling the switches here, we can transfer energy, excess energy from one cell and keep it in the capacitor itself, and then transfer to the other cell. So that is the basic cell balancing circuitry. We can also use inductors for this purpose. So while comparing the active and active balancing methods, of course, active cell balancing methods is more efficient compared to, as we know, it is more efficient compared to the passive cell balancing methods. So in active cell balancing method, these are the different methods that we have seen. Switched capacitor method, then triad switched capacitor method, multivariant transformers, and then we have inductor method, using cuck and flyback converters. Many methods are there. So in all these methods, we can see that switched capacitor is very simple and also very good in performance. So we can simply go for, there is a most simple method for that can be used for cell balancing, switching capacitor methods. And the other method, the circuit become more complicated. That is the main reason. And so we can basically in most of the active balancing circuitry, we go for switching capacitor method. Now, um, yeah, actually, while we are thinking about a balancing circuitry for a electric vehicle storage system, of course, the first setup coming into our mind is switched capacitor method. But while we are using that in the real system, there are many issues. I mean, we have to always monitor in real time, and active balancing circuitry is to be worked in real time itself, because every time we are using that battery in the vehicle itself, then the vehicle is undergoing different driving cycles, or maybe it is mean accelerating, decelerating, or maybe the regenerative mode, or maybe in many modes. So every time, for each part of the system or part of that cycle, drive cycle, we have to monitor the system, and in real time we have to understand whether that particular, each and every cell is in the balanced mode or not, and in that way we have to implement. That means the main thing is we have to implement the active balancing method in real time. Then switching capacitor balancing method is one of the efficient method, but the balancing speed is limited. That is the only problem with switching capacitor method. The balancing speed is limited. So every time we have to monitor and switch accordingly. Otherwise, we cannot use switching capacitors or that method for balancing the cell. As we already seen in an electric vehicle, we have many uh, battery, many modules, and so many cells in different connected in different methods. So for each and every cells, if you are going for switched capacitors, then the system become heavy, or the overall weight of the in the battery pack along with this balancing circuitry will be high. So we have to always design a system where in that system that designed the cell balancing circuitry is applicable or will have minimum number of components. So we must have some mono balancing, you can say some mono balancing circuitry which can monitor, which can be utilized to monitor and balance each module and each and every cells. So many difficult challenges like this are to be addressed while we are thinking about an active balancing circuitry especially using switched capacitor method. I am always highlighting switched capacitor method because that is a most simple and efficient method, though the speed is very less. Now, coming to the implementation of such a system, if you want to improve the system, then the cell balancing system, then we have to think about the real-time implementation of that. The difficulties, the slow speed or switched capacitor method is to be addressed. Many things like that to be addressed. So we have to have an initial study about the working of such type of capacitors. That is very essential before starting into in any type of intelligent system or any type of system like fuzzy based intelligent control can be possible, or many any intelligent system if you want to incorporate with such type of balancing circuitry. Or if you want to design a mono-balancing circuitry for a entire system, initially we have to have some initial studies about the performance of such type of cells. Let us see some cases where we can initially understand about the performance of the different type of batteries. For example, we can start with some cells with the same SOC level and different voltage level. We know that even if we have the same voltage level for the main cells, different cells, the SOCs may be different. Okay, so if you simply try to balance the voltage, or if you only look at the voltage level of battery, many times your system will fail, because we know the state of charge, the charge inside each cells may not be the same. So uh, many previous circuit, even when we are making a charging circuitry, we always start charging the cell when the voltage is voltage is less. That is our basic thing. But when we are using many cells, sometimes we have seen that the cell, when we are measuring with a voltmeter or with some other device, we can see that the voltage is full. But when we are connecting that cell to the system, it may not work. So there is not sufficient charge inside it. So SOC is an important parameter. So it is better always to incorporate SOC also while designing such type of charging and charge balancing systems. SOC, we can analyze a circuit with balancing circuit or a simple cell itself with same SOC and different voltage. The cell voltage of external, if you take this particular system, you can see that with some external charging method, if you charge a cell with a different SOC, you may, if you go on charging it, you may not get the same voltage, even though you are charging all the cells almost same voltage level initially, but your end voltage will not be the same. There may be much difference. Some of the cells will get the same voltage, but the other may become overcharged, or over the voltage may be more than the rated voltage. So that is one of the problems. So similarly, if you always try to, so always we have to monitor both the SOC level and the voltage. Then together you have to monitor and reach the last point of the charging level. There is a maximum voltage up to which we can charge, can be monitored by monitoring both SOC and cell voltage. I have published one or two papers along with my research scholar. You can see that I will share that paper to the coordinators. You can go through that papers and understand how can we simulate these batteries, and also in practical cases also how can we do such type of studies. While charging and discharging, it was seen that see, these are the initial charge, fully charged cells. SOC of cell, for the first cell and second cell, initially it was fully charged. Once you are discharging it, around 50% discharge is done, then we can see that it was found that the first cell, the SOC level was 48, and for the other cell it was 40. So in this particular level, see, this particular case is actually a vehicle can with the fully charged battery, and then we are using that energy stored in the cell. Now, when it is discharged at 50%, we can see, we have observed that these are actually simulation studies. uh, it was observed that the voltage levels, sorry, the SOC levels were 48 and 40% only compared to the 100% level. We have gone for a 50% discharge. So there may be some loss in one of the cell, and in all the cells there will be losses. Now, under this condition, if you go on charging it, then from 48 to 50 percentage, charge is now replaced by charging it. In that case, we can see that now the cell is reaching up to 98 SOC, 98 SOC, and 98% of SOC, and this is 90% of SOC. So that process, if you continue, so the first case, in the first case, we charged that up to in 98, 50% the charge was replaced, and now the SOC is 98 and 90. Then again, if it is discharged from this level by 60% discharge again, you can see that that becomes that was 35 and 19% that for that selected type of cell. So that process is continued for after again 50% partial recharge, 50% discharge. In that way, it is continued. Then it was seen that after many charge and discharge, the SOC level was only 33 and 9. It is a huge difference was there. Again, if you go for 50% of discharge, then we can see that 50% of charge, we can see that 83 and 59 was the SOC levels. And finally, again, if you are trying to discharge, one of the cell become over discharge 18 and the other cannot supply if you go for a 60% discharge. So that after many charge and discharge in the vehicle, we know that in the vehicle, we know that always there is it is charging and discharging. Charging may be due to regenerative braking also. So that process is continuing, and always we have to observe the SOC levels also. So while considering, even if we are going to incorporate some intelligent system like fuzzy logic controller or any some other system with the charging discharging circuitry, I mean cell balancing circuitry, we have to always look at the SOC level and also the difference in voltage. So when we are considering a battery, we have to always check the battery parameters. You have to monitor, and we have to measure the SOC level and difference in voltage. We usually in the existing methods, we can see that always we just check the average voltage of the battery and the difference in voltage of the battery, and based on that we will connect or switch the capacitor between the cells, and we will try to make the capacity or the charges equal, but it may not work. So it is proposed that we have to use some methods to calculate SOC, and some method calculate SOC and difference in voltage, and then we can use that to for these SOC and difference in voltage, along with if you want, we can use average voltage also to make some intelligent system to generate and switch the different cells, or you can control the switch capacitors between the cells, and we can make the cell balance so that we can improve the life of each pack. So these are some cases. This is the first case, input variable only VD and V average was taken, and we can balance the voltage, and at the same time we can again take V difference, the difference in voltage and the SOC. Then we can try. And in that case, in the first case, V average and VD only if you are taking, then you can see that the cells become not fully balanced. The voltage may be slightly different. So this may cause again problem, because uh, the difference, there may be much difference in the SOC levels, of course, and which is not monitored here. So in that case, for different speeds of the electric vehicle, or for different drive cycles, you can say for the drive cycles, if you go for balancing with only the average voltage of the cells and the difference in voltage, it may not result in a good balancing. So it gradually it is going to affect the system, and the system may get damaged in that case. But if you are using SOC as well, and then the balancing of voltage is almost same for most of the cases. The voltage were almost equal. So if we such type of balancing circuit, we always monitor both uh, these parameters, difference in voltage, SOC, etc. Again, um, while designing while designing a balancing circuitry, these are not the only parameters to be considered. So we can incorporate many other parameters, SOC level, difference in voltage, temperature level. Many systems, many parameters can be monitored with the battery management system, and of course this this balancing circuit is also a part of BMS. But anyway, we can always measure these type of parameters, and then we can design a balancing circuitry accordingly. In this particular paper, we have published one circuitry, charge equalization of electric vehicle battery system using an intelligent controller, where we have used SOC and VD as a parameter. So many other parameters can be used, which will further improve the life of each cell. Now, in all these cases, when we are using, see in this particular figure, you can see that for in battery packs, we have separate switching capacitors. So when we are using this type of, when we are designing this type of circuitry, it is not preferable to make separate circuitry for each module or each cells like that, because that is going to increase the weight of your system and also the cost of the entire system. So always it is better to use some circuitry, a mono circuitry, mean one circuitry which can address all the modules. Okay, so we can design a single circuitry, and all these circuitry single circuitry itself can be switched to various type of various modules, so that the battery cell, each of the cells can be balanced. So some methods you have to devise. I am not going to discuss how these can be devised, but some methods can be devised. Of course, that may be this can be using some fuzzy logic switching, or maybe some other AI technique for switching, generating the switching, so that we can connect the single balancing circuitry to all these modules one by one where it is required, because we can always monitor the SOC levels, the difference in voltage in all these cells. So effectively we have to decide which cell is to be which cell become overcharged, or which cell become over discharged. So everything you have to monitor, and according to these data, you have to select, or make an algorithm which can be used to switch the modules, the single balancing circuitry, all these modules. So if you mean using the initial voltage SOC and the final balancing voltage, sorry, the SOC levels and difference in voltage, which I have used for this purpose. For four modules, module 1, 2, 3, 4, and then a single circuitry is used along with physiology control. So here I have we have done a work in the physiology using physiology controller, and now I have seen some other papers where people are using other optimization tools also for switching the single balancing circuitry for balancing the voltages, balancing the cell voltages in different modules of an electric vehicle. So we can try with other optimization methods to of course, switch the mono balancing circuitry or the circuit which can be used for balancing the cell voltages with some AI techniques. While considering the parameters, you have to select the difference in voltage, SOC, other parameters, so that we can get better results. So if you do in that way, then we can use a single circuitry itself, and we can use that for balancing many modules. Now the performance after designing this can be monitored, can be analyzed with a simulation type of system, or maybe using a real-time implementation system. Nowadays, the characteristics of electric vehicle can be simulated or emulated, you can say, in the hardware setup, and hence we can use that for the design circuit with that hardware setup itself, check whether it is working well with the all the modules. In the one minute. So in this figure, I have shown how can we check the designed mono circuitry or any balancing circuitry with the vehicle, with the actual vehicle. So here we have the driving cycle. The driving cycle can be given to the drive controller, and which can be used to charge or discharge the battery system because of the actual we can emulate the actual performance of the system itself, and hence the battery variation can be observed. So that battery variation, again the battery variation can be observed, and the parameters which you have selected for the cell balancing part can be utilized to balance this battery system also. So you can also go through one of the paper which we have published. There is a novel single balancing circuitry for modular cell for electric vehicle application, which is I will share that paper also. I am quickly covering all this, which I am skipping many part. So the novel, we can design a mono circuitry for balancing the entire module. Here, what we have done is the circuitry, which the same circuitry is switched between the modules based on the parameters, either SOC, difference in voltage, etc., or with some physiology controller or some other intelligent system. We can switch the balancing circuitry between the modules so that the same system can be used for utilized for all the modules. Now the modules, as I said, can be implemented in hardware and loop system so that we can understand the basic working of the designed uh, modules or the balancing circuit. See, for implementing such type of system, as I said, initially we must check. We have to check whether the system is performing well with some drive cycle. So, a standard drive cycle you have to select. Drive cycle we have to select, and that drive cycle can be we can use that drive cycle to get the actual variation of charging and discharging of current from the battery, so that the battery will perform accordingly. The variation in the cells will be according to the charging and discharging in sequence that we are getting from the drive cycle. So we can use a typical drive cycle, and the variation of we can understand the variation of charging current and discharging current, so that charging and discharging current can be used for for the system, so that we can measure the variation of SOC in the different cells, and also that we can also monitor the whether the during discharge time or charging time, whether the SOC in the system are become balanced or maybe keeping at the same level, and and we can observe that whether these are keeping at the always coming to the same voltage level uh, along with the charges. Okay, I think I can conclude at this point. I will share all these slides with you because it's a late night now, and I'm really sorry that I have not gone through the details of this because of the limited time. What I want to conclude is that for a electric vehicle, battery is a very important thing, because the life of battery always determine the life of an electric vehicle. So we have to always monitor the life cycle or the life of the battery. So the main thing what we can monitor is the overcharging and the over discharging of the battery system. And for that, we have to always monitor each and every cell. For monitoring, while monitoring that, we have to always keep the charging level in all the cells almost equal or within the limit, not to the maximum level, but to the upper. You can fix some upper limit and lower limit also. Within that range, we have to charge or discharge, which can be which is to be done not only by monitoring the voltage level or difference in voltage level. We have to incorporate some other parameters, especially the parameters like SOC, and always try to design balancing circuitry with simple circuitry, so that easily we can implement it and we can popularize it. And also to reduce the cost of the system, always try to design a mono circuitry, a simple mono circuitry which can be shifted from module to module using some intelligences. Okay, let me conclude at this point. I think you can ask me questions, and I will try to share all these papers and the slides with the coordinators, so that you can go through the papers also. So I think you will get a better understanding about the balancing circuitry and how it is going to improve the life cycle of EV systems.
Thank you so much.